Hello, my name is Armand Tourians. I've been working on this 1974 Triumph TR6 for about 3 years. I'm recording this video to encourage my friends, co-workers, and any car enthusiasts to follow the path and hopefully get their car in a electric mode as I have with this TR6. So the project started 3 years ago with me taking a car and wanting to put an electric motor in it. The mistake that I made was that I bought a car that was not in a very good shape. I was not interested in restoring the car. I was interested in turning the car into electric. But unfortunately, because of the condition of the car, I was forced into actually fixing the body, fixing the paint, fixing all of the components around the car, brakes and everything else. But now it's done. 3 years has gone by and the project is done. The work to actually get the electric motor into the car would have taken 2.5 months, which it did actually. Originally when I started, it was 2.5 months. The car engine was out, the electric motor was in, and the batteries were running the motor. Everything was okay, 2.5 months into it. But since that time, it has taken me to bring the car to the condition that is in today. I will review what I've done with the car with you, so you have an idea and you have an opinion on, or you have an idea of what I have done and what can be done with other cars. So in order to show you, I have to open the hood and show you what is under the hood. The couple of companies that have helped me bring the car to this stage, the paint and the body work was done by my friend Masood in Eurocar in Fremont. He did a fantastic job of fixing the car body and paint, even better than the original paint was when they manufactured the car. Other than that, all of the electrical components I bought from EV West, and also the parts from Moss Motors for the TR6. If you wanted to go the TR6 path, you would have to buy all of the parts from a company like Moss Motors. But the electric parts from EV West. In order to get the electric motor into the car, what I had to do was to remove the engine, which was about 350 pounds of weight. Remove the radiator, remove the charger, remove all of the generators. Everything that was related to the electric gasoline engine running, I had to remove. The replacement was an electric motor, which is right here. I hope you can see the motor. It's about 90 pounds of a round shape electric motor down there. And how you have to connect this to the wheels is to either directly connect the electric motor to the differential in the back or through the transmission. In order to connect it to the transmission, you have to come up with an adapter, which I designed. It's for this car, it's not readily available. For other cars, they're selling the adapters online. But for TR6, that doesn't exist. So I had to design a metal adapter that would connect the electric motor to the clutch, which then connects to the transmission. The motor then gets mounted in the engine compartment on the motor mounts, on the original gasoline engine mounts, and functions as exactly the electric as the gasoline engine would. The horsepower on the original engine was 100 horsepower. I replaced it with an electric motor which was 134 horsepower. And so as a result, the car has a lot more power. It's not directly comparable to the gasoline engine, but still, the raw horsepower for the electric motor is 134. The gasoline engine was 100. Other than the motor, I had to use batteries. So I used 5 Tesla batteries, 2 of them in the front in this cage, mounted above the electric motor. And the the total battery power is divided into 2 separate sections. 2 of the batteries are here, 3 of them are in the back, which I will show you in a few minutes. The total battery power that I have is 125 volts. The battery is 200, and total capacity of the battery is 232 amp hours. So that'll give you quite a lot of power to drive the electric motor and this car. The weight of the car is at about 2,400, 2,350 pounds. The original weight of the car with the gasoline engine and with all of the rest of the components, plus the gasoline full tank in the back, was about 2,500 pounds. That has been reduced to about 2,300 pounds because of all of the components that are removed. As far as the electrical, the low power electrical, the 12 volt electrical, everything is exactly the same as was before when it was manufactured. So the car has 2 separate electrical circuits. One that is the 125 volt, fuses and everything else is in this box. So if anything goes wrong, the 125 volt fuse will pop. And there's also other fuses here that if the high voltage has any issues, those fuses will pop. This is probably the most dangerous part of the car. The electric speed controller is this guy here. This is the computer that drives the electric motor, manages the battery, and communicates with the driver all of the information that is necessary over a few different communication buses that it has. The 12 volt for lights and everything else, the doors and switches and seat belt and all of that is driven from this area. And I've tried to keep almost all of the electrical wiring the same as it was before. So otherwise the windshield wiper and all of the mechanical stuff are all the way it was before. Let's go back to the back of the car and I will show you where the other battery is. So in order to fit the additional 3 Tesla batteries, I had to design this cage in replacement for the original gasoline engine, gasoline tank that was here. So I've replaced it with battery instead of the gasoline tank that was here. The charger is this big thing here, which connects to 220 or 110 and charges the car in about somewhere between 7 to 8 hours. Then I have the Jetson Xavier NX, which is the product our group at NVIDIA is designing. The Jetson NX communicates with the motor and gets a bunch of information from the motor. It gets the RPM from the motor, the speed, and all of the battery-related information. And so it allows me to run the tachometer. It allows me to run the front gauges, which I'll show you later on. It also connects to the LiDAR and to cameras that are mounted in the car for safety. The cruise control is managed with that. And a few other things that, like for example, the battery temperatures and things like that are read by the Jetson. The Jetson work is ongoing. None of it is in completed mode. There are pieces and parts of it that exists, but now that I'm done with the car, now I can focus on getting that part done. So the car gets charged from this inlet here. This used to be the place where you would put the gasoline pipe or the gasoline hose in here, and you would fill up the tank. Instead, I've changed it to an electric inlet. You plug in the electric the adapter in here, and it charges the car batteries, as I said, in about 7 to 8 hours. It's very convenient, and it's a good place to have that. So the cabin, I've kept exactly the way it was originally designed. The dashboard is the same. All of the dials and all of the components that switches and components that are on the dashboard are all kept the same. The speedometer is connected to transmission, so it's functioning exactly the way it was. The tachometer is connected to a motor that is turning based on the information that is going from the electric motor to Jetson, and then Jetson turns the motor so that I can see how fast is the RPM going. The temperature sensor for the car used to be the oil temperature sensor or the engine temperature sensor. Now it's connected to the batteries. The battery computer is this round thing here, and it shows you how much power do you have, exactly how much current is the car using, and the state of charge and all of that comes from this display here. This is going to show the fuel similar to this, except with the old analog, again coming from the NX. NX will be driving a voltage here based on the information it's getting from the battery. And this is actually showing the power, 12 volt power in the car. So when I turn the car on, there's a vacuum pump, the electric vacuum pump that starts. That display here is showing information about the motor, and this display here is showing the battery state. So that, what you're looking at right now, is the main display for the electric motor and the speed controller. If there's anything wrong with the car, or if the car goes into any type of diagnostic mode, or anything goes wrong with the motor, that display will show you what the issue is. The car, as I said, it's a standard shift, so you have to go into first gear, second gear, third gear, fourth gear, and you have a clutch that you have to use in order to do this shifting. The shifting is, or the clutch used for shifting is a little bit different than a normal standard car, standard transmission car that has a gasoline engine, because the gasoline engine never stops. So you have to hold the clutch if the car is not moving, or if the car is in a gear and you want the car to stop, you have to press the clutch. In this situation, that is not the case. I'll show you when we're driving the car, but the electric motor stops. It comes to a full stop. So as a result, you don't need to push the clutch. Other turn signal, the overdrive for the transmission, and the high beam, low beam works exactly the same. The rest of the lights, seatbelt sign, and all of these other things are all the same. The one important area that I've worked on for a long time to get it working is the radio. The radio is the original radio that was installed in the car, and of course electronics components do not last very long, but this is 46 years old, so there's a bunch of stuff that I had to do repair inside in order for this to work. So when I turn this on, the antenna will start coming up from the body, will go up, and the radio will have an antenna.
Him with a pen, the fancy kind that came in a box.
Radio actually is pretty good.
Oh, for the love of St. Nicholas, Santa had said. What good is a pen?
And when I turn it off, the antenna goes back into the body of the car and it stops. So the convertible top, normal convertible tops and standard TR6, nothing changed. The only change in the interior of the car that I've done is I've turned it from the car interior was all black. I've turned it from black to honey tan for the chair, for the seats, and also the walls. The interior lower part is all black. Otherwise, colors, everything is the same as it was manufactured in 1974. So now, let's go and take a drive with it and see how it feels. Okay, so now the car switch is where it used to be, exactly the same way the car starts. The electric vacuum pump starts in order to give us a good brake, and then the car will be ready when the camera detects me as the person that is supposed to drive this car with facial recognition. Now I can actually drive it. So I will hold the clutch, put the car in the reverse gear, and the car is ready to go. So we are moving now. The battery shows that we have, the display shows that we have about 30% battery life left. That means I've been driving the car for the rest of the 70%, which is total, the total battery capacity is about 70 miles. So once you run out, the car will stop. Now you have to charge it. So I was in reverse gear, now I'm in the forward first gear. Car starts, electric motor starts from 0, now it starts going up. And as long as I am below 30 or 40 miles, I don't need to change gear. But when I start going above that, now I have to go into second gear. So right now I'm in the first gear. I don't have to hold the clutch because the electric motor does not have to run. So it's, when I stopped, the electric motor went to 0 as the gasoline engine. Now I'm in first gear. I am going to about 25 miles. Now 30 miles. And again, I don't have to change to second gear because I haven't gone above the speeds that would require the change. Transmission is doing okay. So again, I stopped without the clutch. Now we are going about 25 miles again. Now I have to change gear. So I'm at about 30 miles, clutch, and the car went into second gear. We're doing about 35, 40 miles an hour now. I shouldn't really be doing that fast in the street, but in order to show it to you, I went a little bit above the speed. So when you go into a complete stop mode, it will be best if you shift it into first gear and then start again, just like you would with a gasoline engine. So, car is running. I'm in second gear. The total distance that the car will travel with these batteries is about 70 miles. The weight of the car is very important for the distance that you're going, so depending on how many people in the car or what you have in the car will determine if it's more or less than 70 miles. So far what I've tested is that it's a 70-mile distance that it will travel with the batteries that it's got. The electric motor is from a company called NetGain Motors. They have a few different kinds of motors, faster, slower, and you can also use the Tesla motors if you wanted to get a lot more power than 134 horsepower that I've used. It's a wonderful concept, and if you are mechanically inclined, electrically inclined, or if you just want to do this using a company like EV West to do this for you, you will enjoy this very much. The car drives fantastic, much better than its original drivability, and it's just fantastic to know that you're not polluting the air and you got an electric car, and it's also your favorite old classic car. Thank you, and if you have any comments or if you want to ask questions, send me an email or call me at my phone or at work. I can talk to you about different things that I've done with Jetson. Good luck.